Sketch a graph of f. For part A, we have f of x equals negative 2x plus 1. We'll make a table of values, and we'll select 3 points to be able to draw this graph. We're going to substitute negative 2 for x. Negative 2 times negative 2 is positive 4 plus 1 is 5. And these are our y, which equals f of x values. For 0, we have negative 2 times 0, which is 0, plus 1, which is 1. And for 3, we have negative 2 times 3, which is negative 6, and negative 6 plus 1 is negative 5. So let's plot these points, negative 2, comma, 5. Negative 2, comma, 5. Then we have 0, comma, 1. And then finally 3, comma, negative 5. 3, negative 5. And now we draw what should be a straight line going through those points. So a little bit off there, but then this is the graph of f of x equals negative 2x plus 1. For part B, we have f of x equals x squared plus 1. First, we ought to remember that this is the shape of a parabola, so we have an idea of what we're going to draw. Again, we will select values of x, substitute them in for x to calculate the value of f of x. So negative 2. Now negative 2 quantity squared is positive 4, plus 1 is 5. Negative 1 squared is positive 1, plus 1 is 2. When we substitute in 0 for x, we'll get 0 squared, which is 0, plus 1, which is 1. When we substitute 1 for x, we get 1 squared plus 1, which is 2, and then 2 substituted in for x, 2 squared is 4, plus 1 is 5. So we have the point negative 2, comma, 5. We have the point negative 1, comma, 2. 0, comma, 1, and then 1, comma, 2, and 2, comma, 5. So now we can see that the shape of our parabola would be this. And so that's f of x equals x squared plus 1. For part C, f of x equals the square root of x plus 3. Let's start by substituting negative 3 for x. Negative 3 plus 3 is 0, and the square root of 0 is 0. Now, I started at negative 3 because I did recognize that if I started with numbers less than negative 3, that when I added 3 to them, that would leave a negative number underneath the square root. And that does not yield a real number solution. And therefore, negative 3 was the first number to plug in with respect to the domain of that function. When we substitute in negative 1 plus 3, that's going to be the square root of 2. When we substitute 0 for x, we get 0 plus 3 for the square root of 3. When we substitute 1 for x, we get 1 plus 3, which is the square root of 4, and that's 2. And when we substitute 3 for x, 3 plus 3 is 6, so we get the square root of 6. Let's plot these points. Negative 3, 0 would be right here. Negative 1, and then the square root of 2. If you were to substitute that into a calculator, you would find that it's approximately 1.4, etc. So the 1.4 is sufficient for what we're doing. So negative 1, 1.4. Then we have 0, square root of 3. Again, substitute that into a calculator, and that's approximately 1.732, etc. So it would be 0, 1.73, etc. We have the point 1, comma 2, 1, 2. So you can begin to see that the shape of this is the square root function, and we have just one more point, 3, and then the square root of 6. Now the square root of 6 is, of course, between 2 and 3. So it would be approximately there, closer to 2 than it is to 3. And the reason we're saying that, if you didn't have a calculator, you know the square root of 4 is 2, and the square root of 9 is 3. So the square root of 6 is between them. But our graph then would look like this. And it's a curved line starting here and then going on to infinity with respect to both the x and y values. For part D, we have f of x equals the absolute value of the quantity x plus 1. Again, we will pick some values of x, substitute them to evaluate f of x. Let's start with negative 4. Negative 4 plus 1 is negative 3, but the absolute value of negative 3 is positive 3. Now substituting negative 1 for x, negative 1 plus 1 is 0. And of course, the absolute value of 0 is 0. Substituting in 0 for x, 0 plus 1 is 1. The absolute value of 1 is 1. Substituting 1 for x, 1 plus 1 is 2. Absolute value of 2, 2. And finally, substituting 3 for x, 3 plus 1 is 4. The absolute value of 3 is 4. Plotting these points, we have negative 4, comma 3. Negative 4, comma 3. Then we have negative 1, comma 0. That would be right on the x-axis. 0, comma 1 would lie right on the y-axis. Then we have 1, comma 2, 1, comma 2, and then 3, comma 4, approximately there. And so remember, the shape of an absolute value is V-shaped, so you can see that what we have going on is our V with the turning point at negative 1, comma 0. And this is f of x equals the absolute value of x plus 1.